As questions come up with your MATLAB programming exercises, I will encourage you to contact me via email and ask me specific questions about what sort of demos you'd like to see in terms of helping me facilitate you learning MATLAB. The questions I got asked this week were, how do I actually get my data into MATLAB? And specifically, how do I get data that is not necessarily complete? And so this is kind of real world exercises that you guys are doing here with your Adopt a Climate Station exercise. And oftentimes there's missing data, meaning that observations were not taken, or the person that was recording the temperatures was on a hiatus for a while, on strike from the National Weather Service, whatever other reasons there might be. So let me actually do two things here in this brief demo. Let me show you how to actually get that data and identify a way to eliminate missing data. Okay, and then I also want to show you how to convert that data, which is in units of degrees Fahrenheit and in units of hundreds of inches of precipitation, into standard metric units of degrees Celsius in millimeters. So first I'm going to take my climate station here, and I'm going to use Kellogg, which has the 4-letter identifier here. Click on Get Monthly Data, and it will actually download that data to a CSV file. You can open that, and if you have it situated correctly, it'll open it up to an Excel file. Okay. When you open up your Excel file, what you'll see is the data, and again, I gave you the directions of what these columns represent, but basically we have the year, month, we have the average high temperature, average low temperature, we have the precipitation amount, and then we also have the snowfall accumulation. Now, you can work with the data in Excel, and that would be okay, acceptable. It may be easier at first sight to do that in Excel. However, as we get more and more involved, it might be actually more difficult to do it in Excel. So I'm going to encourage you to do this in MATLAB. And to help you out here, one thing that we can see initially is with real data we have missing data. There's M's in there, and this means basically that that we have to deal with those problems. What I will suggest you do is do a search and replace for the M's. So if we go to find, search and replace, that would be in edit, and we go to replace. And what I'm going to do is replace all M's in the data, which M is denoted here as missing. We're going to replace those with something called not a number. Okay, and we're going to type that as capital N, lowercase a, capital N, and we're going to hit replace all. Okay. Once that's done, what actually happens is that now we have NaNs where we previously had M's. Okay. Now I'm going to open up MATLAB, and I am going to actually copy that data into MATLAB. Now you might consider that you have a column here which includes the year and the month, and that might be somewhat problematic when importing data, so you've got to think about how to deal with that. I might actually suggest that you start importing data on a January rather than start importing it on a February. So in this case, we here see that Kellogg starts in February. Let's start on a January. We'll just eliminate that first year of data. Okay, and we're going to do a copy and paste. It's easier that way. There are better ways to do this, but copy and paste should suffice for our needs. We're going to basically copy and paste all the data from 1906, okay, through the period of record. And that should take us up to 2011. Okay, so there's 2011. I'm going to copy that. Okay, and then I'm going to go into MATLAB here and just create a dummy variable like we did before. Dummy equals, and then again, square open bracket, paste, square close bracket. Okay, and so I did that, and there's going to be a couple things here now. First of all, you can see that if you do size of dummy, size basically tells you the dimensions of that array. Okay, so we have 1272 by 5. And what that means is that we have 1272 rows by 5 columns. Okay, the 5 columns, first column is kind of date stamp. Then we have a column for Tmax, Tmin, precip, and snow. Okay. And what we'll also see is that those NaNs were read in. If you have M's in the data and you try to read those M's in, MATLAB will yell at you and give you red text and probably squawk at you. Okay. Now, we have sequentially entered in the data starting from 2006 through 2011, and those are monthly data. Okay. So what I might suggest to make this easier is you should know that if you're entering in data that starts in January and ends in December, you have 12 months of data times however many years of data that you have. And we can see here that 1272 divided by 12 is 106 years of data. Okay, so what I might do to make this easier is to create a new variable. We're going to actually get rid of the time dimension. Okay, we're just going to know how the time dimension works. Dummy2 equals dummy of colon, everything. We want everything in that. We want all rows, and we want just columns 2 through 5. So this first column is year, month. We know what the year, month are. Okay, we're going to do that. And now dummy2, okay, now that's just 1272 by 4. MATLAB has the nice functionality of allowing you to use matrices to your advantage. Okay, so we have a matrix here. And what I want to do now is actually reorder the data so that I have variable, month, and then year. And if I have the data like that, it's much easier to work with rather than having the data ordered sequentially month after month. So to do this, I'm going to take 2 steps here. I am actually going to first flip the dimensions of dummy2. So all I'm going to do here is say dummy2 equals dummy2 and then put the tick mark. Okay, and that's the key right next to your enter or return key. And what that's going to do, and if I put a semicolon after it, what that's going to do is basically change the order of your array. It's going to flip it. Okay. The next step here is that I'm going to take that 1272 and I'm going to convert it into a 12 by 106 matrix so that I have variable, month, and then year. So I'm going to create a new variable, dummy3, and I'm going to use a function called reshape. Okay, reshape basically takes data and then it forces it into a different dimension size. So reshape dummy2. First I tell the variable that I want to reshape, and then I basically say the size that I'd like to reshape it into. So it's still 4 variables. I want it to be 12 months and 106 years. Okay, so when I do that, now I can see size of dummy3 is now 4 by 12 by 106. So the nice thing is that now I have all my Januaries basically in if I want to make a time series of January temperature, I could do plot dummy 3. Actually, I'm going to use a squeeze before it. Dummy 3 of Tmax January's month 1, and year is in the 3rd dimension. I can do that, make a plot, and what comes up now is a time series of January temperatures for Kellogg. And you can do the same thing with any other month, and you can now easily plot up all months if you wanted to average over all months, for example. Okay, so that's the first step. You'll also note that we have our missing data in MATLAB. If you have the NaNs in there, it will just ignore those values. Okay, it'll just completely ignore